Hello, this is Ben from Project Code, and in this short video, I'll be introducing to you the Turtles module. So without further ado, let's dive in. So the most important piece of code is this piece of code. So this piece of code just essentially allows us to use collab turtle in our notebook. So if you don't run this code, none of the following code blocks will actually work. So make sure you run this piece of code and you get this requirement already satisfied message. Next, we'll move on to the initialize turtle function. So this function essentially just activates the screen, so it just prepares the paper for us to draw on. Also, remember to call the initialize turtle function at the start of every code block so that a new screen is formed, because we don't want our new drawings to overlap with our previous drawings. Now, let's take a look at how this code works. So we'll start by looking at our turtle. So in Google Colab, the turtle is always in the center of the screen, pointing upwards, vertically upwards. So by using the t.forward 100, we actually move forward by 100 units. Next, so now we're still pointing upwards, and in the second line, we're actually moving towards the right. We're actually turning 90 degrees towards the right, so clockwise. So now we'll be facing here. And in the third line of the code, we're using t.forward 100, so we are extending by another 100 pixels. And then in our second turn, we're actually turning 90 degrees clockwise again. So now we'll be pointing downwards because we're doing another turn 90 degrees. And then we'll extend by another 100 pixels. So this will be our third side. Lastly, we'll do our last and final turn. So we're turning 90 degrees clockwise again. So now we'll be facing this part. And then we'll just extend by 100 pixels to complete the square. So this is where we actually end off, and which is also where the turtle end off. So you can actually see how this works by running this piece of code. So it will be exactly the same as how we visualized. So this part here is essentially where you can use iteration to reduce the amount of code you need to write. This is because these two lines are repeated 3 times. Hence, we can use a for loop to reduce the amount of code that we need to write. This allows us to illustrate the importance of iteration to them. Next, we'll be moving on to drawing some simple letters. First, we'll start with the L shape. So, as usual, the turtle is always pointing vertically upwards at the beginning. Then we'll move forward by 100 pixels. And then we'll move backward by 100 pixels. So we go back to our start point. So when we go back to our start point, we are still facing vertically upwards. Now we are turning towards the right 90 degrees. So now we are turning clockwise 90 degrees, which is this part. So now the turtles will face here, and then we can extend by another 100 pixels to form our L shape. You can show this by running our code. And done. Lastly, we have the T shape. So the T shape is a little bit more challenging. So first, because the turtle is always pointing vertically upwards at the beginning, then we turn towards the right, 90 degrees clockwise. So now the turtles will point here. And then we move forward by 50 pixels, which is half of 50. So we'll move something like this. Then we go backwards by 100 pixels. So we'll go, so because this is 50, right? We go back to the start point, so this is 50, and then we go back again. So then it's 100. So the length of this is 100. And then notice our turtle will be here, but it'll still be pointing in this direction. Then we go forward. Okay, so after going backward by 100 pixels, we're going to go forward by 50 pixels. And because we already went back by 100 pixels, if we go forward by 50 pixels, we'll be at the start point, our initial start point, which is also the midpoint of this line. Then we'll turn towards the right 90 degree clockwise. So we'll be pointing downwards. Lastly, we'll move forward by 100 pixels. And this is how we actually get our T shape. Lastly, we have a fish. So this simple fish is made up of a square and a triangle. So we have already pretty much thought of the logic as well as the mathematics behind drawing this such a shape. So all the children have to do is to play around with these values to get the optimal values to form a perfect triangle with the square. So I'm just going to erase this. So the variable short sides length, so this variable actually refers to the length of the two equal sides here. This is because this triangle is actually an isosceles triangle, where the two sides here are equal. The long side length refers to this length, which is the hypotenuse of the triangle, the longest length, the longest side in this triangle. The obtuse angle refers to the angle that the turtle needs to turn. I'll illustrate this with a simple drawing. So let's say we have a line. So let's say we have this line. Okay. So this line is parallel to this line. Now, we need to turn, right? Because now our turtle is going in this direction. And then we need to turn upwards to make a straight line upwards. Because it's this part of the line. And then we need to make the hypotenuse, which is a straight line upwards. And then if you were to extend this line with a dotted line, this angle here refers to the obtuse angle. Okay. So in the same way here, if we go forward by this amount, certain amount, and then we need to turn again, okay, to complete this triangle. So we go here, and then we need to turn. So we're going to turn in this direction. So if we were to extend this line with a dotted line, this angle here is our obtuse angle. And because this part here is an isosceles triangle, so if we were to label this with angle A and angle B respectively, the value of angle A is equal to value of angle B. Hence the value of these two angles is the same. Hence we can refer to them as the same variables, obtuse angle, because both of these values are the same. Okay, so these are essentially what these terms mean. So to recap, these two sides here, okay, because it's an isosceles triangle, these two sides are the short sides length. This part here is a long sides length. And lastly, this part here, these two angles, is the obtuse angle length. Lastly, we end off by teaching them about colors. So we'll teach them how they can actually customize their drawings with custom colors, such as orange or a multitude of colors. Finally, we end off with a congratulatory star message. Fun fact, this picture was also created with turtles, and this is how the code looks like. We have two layers of loops. So I'm going to extend. So we have two layers of loops. Okay, so the first loop is to decide the color, the position, the X and Y positions of the stars. The inner loop is to draw the actual star. Yeah. Okay, so this ends off this video. I hope this video gives you a rough idea of what turtle is like. And if you have any questions, please do not hesitate to contact any of the project code team members. Thank you.